My name is Mario Fusco. I work for Red Hat just for a few next week. Then we will be moved to IBM, as you probably know. I'm the project lead of Druze, which is our rule engine, but also I'm one of the committer of these two things, Quarkus and LangChain4j. I'm mostly working on LangChain4j these days and on the Quarkus integration with LangChain4j. So first of all, let me clarify something. I'm going to speak about. Sorry, 1 second. Okay, I'm going to speak about AI. So the natural question is, are you speaking about AI in Java seriously? Don't you know that the whole world is doing this thing in Python? And the answer is that yeah, because I'm not a data scientist, you know. So the fact is that sorry, 1 second. Okay, The fact is that I'm not a data scientist. What I do is I take existing model from Hugging Face. I don't create the model myself, and then I do the integration of this thing, right? And to be honest, do you really want to do this stuff in Python? I mean, do you want to create your own enterprise project with a language like Python that, in all honesty, is just 2 orders of magnitude slower than Java? It's just because of this, but because of all the goodies that the Java enterprise ecosystem gives you that you don't want to lose. So I'm not creating a model, I'm integrating them. So why I should do this in Python? It's perfectly fine, and I guess even much better to do this in Python. So the message is that, okay, I'm happy it works on your Jupyter notebook, but you know, we are not going to put your Jupyter notebook in production. So it's perfectly nice, perfectly fine to do this in Java, okay? And sorry, maybe I can get rid of this. Okay, better, okay. It's a bit. Can you please help me, because it's a bit cut. I don't know what this thing is doing. Sorry, guy. Okay. That's better, much better. Okay, thanks a lot. Sorry. So the fact is that there are lots of roles in this AI game. There are the data scientists that are working on the model, and there are the platform engineers that are making this model available for the end developer to integrate them. And there are the AI engineer, and I think I'm an AI engineer this day, or I'm a prompt engineer if you want, even if I don't like the term. And then of course there are the end user, where that are the final target of this system that we are trying to create, or these AI-infused programs, okay? So just to introduce the Agentic AI, we have this great thing which is machine learning, that you know, you need to be careful or which data you feed in it, because if you feed shit in, you will get shit out. And then we will make it more shining and more colorful with generative AI. And now, of course, the end result that we are getting with Agentic AI is that we are creating microservices of this little nice, cute shit. Sorry, and we are trying to make them work together, right? So this is the essence of Agentic AI. But no, in reality, Agentic AI is something extremely powerful. And I must admit that I'm playing with this thing since a few months, and I can stop being surprised of what you can do with this stuff. So what Agentic AI is that basically you provide an LLM with some external things, like the possibility to call external tool, external function, the possibility to access data sources to implement the RAG pattern, for instance. And the other aspect is that typically the LLM are stateless. They don't have a memory, so every time you talk to an LLM is supposed to start from scratch to forget what you said before. So the thing that we do is that we provide this thing also with memory, meaning that every time we have a longer conversation with the LLM, what we are actually doing is that every time we are sending back and forth the entire conversation that we had so far. Okay, and then so this thing is made of different components. Of course, the core of this thing is the AI model, and as I said, to implement this agentic pattern, you have to complement this with different components and with different purposes based on the goal that you want to achieve. Okay. The main, as I said, I started experimenting with this agentic AI pattern since a few months. The main difference that I found is that we have these two families of pattern. One are what we call the workflow pattern, meaning that yes, you have different LLM, but the work of this different generative AI system is orchestrated from the outside in a programmatic way. So you create a programmatic workflow of this LLM, and you combine their work, but how they are orchestrated is made in a programmatic way, okay? And on the other side, we have the pure agentic pattern, where this time we are no longer in control of the workflow, okay? So in the first case, we are in full control of what's happening. Yes, the system is still not totally deterministic because of the stochastic nature of the LLM, but still we are in control. In this second family of patterns, you are no longer really in control of the workflow. You are also delegating the action plan, the workflow, what's going to happen to the agent itself. So it's the agent that is now in control, and it is the agent that now decide what to do, okay? So all the examples that I'm discussing in this talk are available at this project. You can simply download the project on the GitHub repository and try them on your own. A few notes about this example. First of all, I wanted something that runs locally, okay? I didn't want to rely on external services. First of all, because I don't want to pay for them. Second, because I don't want to send my prompt to external services and I don't know how they are using them. And second, because I wanted something that simply runs on my machine and I can experiment with it even without an internet connection. And also because I wanted to demonstrate that you can do this stuff even with a relatively small model that can run on your own laptop, okay? And this model actually can run on your laptop with reasonable hardware. I don't have any special hardware to run this thing. And they can run, all these examples can run, let's say, in reasonable time. With reasonable time, I mean a few minutes, okay? So I'm not going to do any live demo today just because any of these demo take, you are here waiting 3 minutes for this thing to be generated. Probably is something that you don't want in a live talk, but again, you can try them on your own, okay? And then the other thing is that if you look at the examples that I have, the traditional part of software development is mostly glue code, nothing more. It's very limited, and in reality, it's a very small fraction of the work that I've done to put this thing together. What takes you time is to decide which model fits best the problem at hand, okay? Especially with this small model that I'm trying to use locally. There is no model that works in all situations, so you spend lots of time basically doing trial and error, trying different models, and check the one that works the best for you. One problem with this workflow at this moment, in my experience, again, I tried different models, taking them from Hugging Face, for instance. The problem that I found so far is that I miss a taxonomy of this model at the moment. I would like to go on Hugging Face and say, okay, this model is very good at tool invocation, or it's very good if you have a RAG pattern, then use this tool. This model, okay? We don't have this yet, and it's something that I really miss. I would like to have this, but since we don't, you need to do some trial and error, and then of course, crafting the right prompt takes you a lot of time. And then, of course, if you have a prompt that works for you, and then you try it with a different model, the result is totally different. So, and then you have to rewrite the prompt from scratch. So that's the thing that takes you time. And the other aspect is that hallucination are still a problem, will be a problem forever, probably, with this kind of model. And what's interesting is that, as I said, I'm using a tool. What happens quite frequently is not only hallucination on the text that the LLM generates. It's hallucination also on tools invocation. So from time to time, I tell to the LLM, look, you have the tool A, B, and C, and then the LLM asks, okay, I need to use the tool B, D. That, of course, doesn't exist. So you also have hallucination with the tool invocation, and actually, this is something that we needed to address in LangChain4j, because it's something that was so happening quite often. And what you do if the LLM asks to use a tool that doesn't exist, okay? So in reality, you don't know. So what I did in LangChain4j is that now you can plug your own tool hallucination strategy. So you can decide, there is a default behavior, of course, which is simply throwing an exception, but you can plug your own behavior if you want in LangChain4j. Okay, so let me give you a few examples of the first family of workflow that I mentioned it before, that are the workflow patterns. So this is a very simple workflow. What I'm doing here is that I have 3 LLM. One is supposed to write, it's a creative writer that is supposed to write a novel, and then I want to edit that novel in a particular style, for instance, a crime novel. I want to make it as a crime novel, and then I want to re-edit it again for a specific audience. For instance, I want a novel for kids, okay? So what I'm doing here is that I'm just implementing this prompt chaining workflow. So if you look at the code now, as I said, I'm in control of what's happening here. So I ask the creative writer to generate the novel, then I take the novel and I send it to the style editor together with the style chosen by the user, and then I do this again with the audience editor. And so this is the simplest form of workflow pattern that you can use. And the nice thing that you have out of the box with the Quarkus LangChain4j integration is also that you have full audit of what's going on. So you can enable the auditing, and then you can see that, okay, of course, it's obvious what you see now. It takes like 34 seconds for the creative writer to generate the novel, and it took 59 seconds to rewrite it in a proper style, and 59 seconds more to rewrite it for appropriate audience. Okay, so what I'm saying here is that you can have a complete audit, it's totally, this thing is totally trackable. Okay. Another quite common case, which is probably the dual of the other one. And by the way, of course, I can. I'm showing you the simplest workflow, but of course you typically can combine them. Okay, so another very typical use case is that you can use them in parallel. So I want to create an agent that can generate me some advice for a nice evening. So what I have is that I have a food expert and a movie expert, and I ask to the food expert, give me 3 recipes for a romantic evening, and I ask to the movie expert in parallel this time, give me an advice for 3 romantic movie, and then I put all of them together. So I combine the 3 output of the food expert and the 3 output of the agent expert, and create a 3 evening plan. And of course, in this case, as I said, the 2 agent invocations happen in parallel, so you can see that the 2 calls happens at the same time. Okay, and this is another quite typical workflow pattern, which is routing. Actually, many LLM applies this internally, even if you don't know. This is the what is called also the mixture of expert LLM architecture. So what happens inside an LLM is that you may have a big LLM, which in reality is composed by different small LLM. So you have, in this architecture, you have a first LLM that categorizes the user prompt, the question, and then it routes internally the question to a second LLM. Okay, I'm doing exactly the same thing, but with actual different agents, different LLMs. So first of all, I have a router agent. This router agent takes the user question and decide and try to classify it. Okay, so it just returns me a request category, which is an enumeration. So the request category can be legal, medical, technical, or unknown. In that case, I don't know what to do, and I simply return this to the user. But otherwise, the classifier agent decide which of the expert can handle my request. So I have a medical expert, maybe because has been trained with some medical corpus, or it has some medical database connected to do some RAG, but in essence it's a medical agent. And if the router agent says, okay, this is a medical question, then the question is routed with that simple switch to the medical expert. Okay, and this is an example of one of the 3 experts. It's just an AI service. When the user message says you are a medical expert, reply to the user question, and that's all. Okay, and this is all cool. Okay, but let me make another digression about test. Okay, the problem is that this is all cool, but how do you really test this stuff? I mean, normally what you do is that you have deterministic code, you do assertion, and every time you run the test, it happens exactly the same thing. Okay, with LLM, of course, this is no longer the case. So another problem that we have, and on which we are working these days, is that how do you test this stuff? And let me be clear on what can go wrong. Okay, so as I said, I'm a LangChain4j committer. I sent a pull request a few weeks ago, and that pull request was read. Some test was failing, but in a very unexpected way, because it was failing in a module that should be totally unrelated with my pull request, and actually it was. The problem is that the module that started failing was the module for the LLM vision, so image recognition, which again was not part of my was not related at all with my pull request. And if you look at the test takes in input that image of a cat and ask to the LLM, what do you see, okay? And the very simple assertion that we had in this test is that the only assertion we had is that, okay, whatever is the response, the text should contain the word cat. That's the assertion, right? Simple as that. So in reality, at some point, a particular LLM started failing because it started replied with, I see an animal with a feline appearance. Okay, so, yeah, right? But the test is failing. So this is to say that you cannot have any more, you need to have a different approach even for testing this stuff. So what we are doing with the Quarkus extension, we have this still experimental model module that allows you to test an LLM. So what you do, instead of just simple doing a search or assertion with a fixed value, you have a score. You need to say, in a way or another, okay, the output generated by the LLM is okay for me. Okay, so what I have is that when you use this model, your test is injected with this scorer utility, and then it evaluates a set of samples that you can write programmatically, as in my example, or you can have it in a JSON file if you want. And then you evaluate the output of the LLM against a function and a set of evaluation strategy. You can have more than one. So an evaluation strategy is just a predicate that taking input the sample that runs on the LLM and the output of the LLM, and you say, okay, according to my evaluation strategies, this sample has been corrected, evaluated or not. Okay, and of course you can write your own evaluation strategy. As I said, it's just a B predicate basically. In this example, I'm saying that the expected output, which is the classification of the question of the user question, is just the same output generated by the LLM. So I'm just checking if the LLM is correctly classifying my output. Okay, but of course you can plug, you can have your own evaluation strategy. So you can write basically what you want. Again, it's just an interface implementing a B predicate, but of course you have some evaluation strategies that could be very useful out of the box. So you can, for instance, calculate the cosine similarity, the cosine distance between the expected output and the actual output, and say, okay, this sample is okay for me if it's if the distance is below a given threshold. Okay. Or you can, for instance, use the LLM as a judge pattern, meaning that you have a second LLM that decide if the output generated by the first LLM is good or not. Okay, I understand that it's a bit weird to use an LLM to judge the work made by another LLM. When I saw this pattern for the first time, it remembers me of a very old joke about XML that is like 20 years old. At the time we say that XML is like violence. If it doesn't work, it means that you are not using enough of it. Okay, and we are doing exactly the same thing here. We are using more and more LLM until it doesn't work. Okay, of course it's a bit questionable, but it's very common, and I must admit that this pattern works in most cases. Okay, so I discussed about the workflow AI pattern, how to test a single agent, but in reality, as I said, what we are trying to do these days is to delegate to the LLM the full control, the full execution plan of the user request. So in this case, again, you are not writing the clue code. You are not saying take the input of this LLM and pass it to the second, this other LLM, or combine the output of these two LLM and do something else or whatever. But the LLM this time is in control. Okay, so let's move from the workflow AI pattern to the agentic AI pattern. So the very first thing that I did is taking the same routing example that I had made with the workflow AI pattern and making it a more agentic way. What I mean is that this time it's not our code, if you remember. So let me go a little back just to be clear. So if you remember, this is what I had. So in this switch statement, I'm deciding which, based on the classification of the first LLM, which are the second LLM that I want to call. Okay, but I coded this. This is my code. Okay. Now I'm not doing this anymore. I'm saying to my LLM, you have these three tools, which are the three experts that I had before. And by the way, they are exactly the same expert. I didn't do anything. What you can do with Quarkus LangChain4j is that you annotate the LLM with that tool annotation. In the string, you write the description, what that tool is supposed to do. Okay, so I didn't change the existing expert. I just added to it the tool annotation. And by doing so, I'm enabled to use that LLM as a tool for another LLM, which is what I'm doing there. Okay, so I have these three experts annotated with tool, and then I have the classifier expert that is no longer returning me the classification of the response, but I'm telling to the first LLM just forward the question to the tool that you think will be the best expert to reply to this question. Okay, so it's exactly the same thing as I had before, but this time all the routing logic is done by the LLM. It's not written in code anymore. So that's the main difference. Okay, and of course there are pros and cons in these two approaches. Okay, so the workflow approach is a little bit more predictable. You can deal better with hallucination. It's a little bit easier to debug and test because you are testing in isolation the single agent, while in the other case you have one agent is calling the other agent, so you a little bit lose control, which is what you want. I mean, you want to delegate the control to the LLM, but of course this has pros and cons. Okay, so again, the workflow approach is easier to debug and test, and still it enables you to have more complex workflow, meaning that the routing decision, if you write the routing decision programmatically, you cannot base it only on the output of the first LLM, but you can encode more complex logic. Okay? On the other side, however, the agentic approach is much more simpler, meaning that you don't have any glue code to be written. Everything you don't need that switch expression anymore. Everything is done by the agent on its own, so it doesn't require any additional code. And it's also, if you think about it, it's more flexible. Okay, because it's true that with the workflow approach, you can encode different behavior, different classification. But with the agentic approach, you are giving more power to the agent, meaning that if you have a question that is both a legal and a medical question. I had a car accident, okay? I broke my leg, but I also need my car to be repaired. So in that case, I need to interrogate not only one expert, but two of them at the same time, okay? So if you give this thing to the agent, you are giving to it more flexibility. So the agent can realize on its own, okay, one expert is not enough, I need to call two in this case, okay? And of course, you cannot have the same, the workflow pattern cannot have the same power because in that case, you should on your own foresee the possibility of needing two experts and coding accordingly. Okay, which is much more difficult. So the agentic pattern gives you much more flexibility. The other aspect, however, is that if you look at how it works now, the agentic approach wastes a lot of time. Why so? Because so this is the execution of the the workflow pattern. So what happens is take a couple of seconds to decide the category of the request, and then it takes like 25 seconds for the proper expert to generate the response, okay? And here it's happening exactly the same with a lot of wasted time more. What is this wasted time? For how it works, the LLM is using another LLM as a tool. Okay, so the tool is returning the answer to the first LLM, but it's a tool invocation, so it's the first LLM that is still in control. So what happens now is that the first LLM takes some time to do the classification, then it routes the question to the expert, then the expert replies to the first LLM, and the first LLM has to re-edit, reprocess, rework the expert response, okay? And since the expert response is pretty huge, it's a lot of token, it is the most time-consuming part now. Okay, so this takes like 26 seconds, and this takes 2 minutes, because it needs the first LLM need to reprocess the output of the expert of the second LLM. Okay, so this is how tools work. Okay, so we are working on this specific use case, of course, to avoid this situation, and I will have more about this later. But this is how it works at the moment. Okay, so again, there are pros and cons in the two approaches. And then, yes, then I have a few more examples. I played again with this agentic pattern. So here I have a weather forecast agent because, of course, you can use as tool what you want. So I have, in this case, another LLMs tool, and then I have 2 external web services. So, so this thing basically take a question about weather in human language. So the question is, what is the weather in Coimbra? So what this thing has to do is using a first LLM as a tool to extract the name of Coimbra, the name of the geographical location from the user question. And then you have a first web service that translates the name of that city in its geographical coordinates. And then I have a second service that takes the geographical coordinates and reply with the current weather at those geographical coordinates. Okay, so this is all done by the agent. I'm not writing a single line of glue code. I'm giving to the agent these three tools, and the agent figures out alone how to use them. Okay. Here I asked what's the weather in Rome, and then as you can see, it does this processing trying to extract the word Rome from the sentence, and then calling the other two web service to extract the geographic coordinates of Rome and the weather in Rome, and then again the weather service reply with some temperature and weather, and the LLM, as you can see, process the response again from the web service and generate some human readable response. Okay. This is another very nice example, which is something that I advise you to give it a try. What I'm doing here is that I'm providing an agent with a web search tool. Okay, so I'm saying to an agent, try to reply to the user question, and if there is an information that you don't know, go and use this web search tool. Do on your own the search on the search engine. Here I'm using DuckDuckGo just because it's a nice API. Do the search, take the information from the response of the web search, and use that information to give the user the answer to his question. Okay, and for this particular example, this is a little bit more difficult. So the LLM has to figure out, okay, what is the information that I don't have? Is this one? How can I ask it to the web search, and what to do with the web search response, how to parse it. So it's a little bit more difficult, let's say. You need a little bit more powerful LLM. This is the biggest LLM that I used in my example. So what I have is that I'm using, as I said, there is no one LLM that fits all problem. Okay, so what I have is that in the Apache, in the application properties of Quarkus, you can configure different LLM. Okay, here I configured an LLM with the Qwen 2.5 14B model, which is relatively huge to run on my machine. And then you configure it. Okay, I configure it with 0 temperature, and of course I had to use a longer timeouts because it requires more time to run on my machine. And then when you want to use this thing in your AI service, you can simply say, okay, I want that AI service to use that specific model. Okay, so you can configure multiple models in your application properties file, and then you can use different models for different AI services. Okay, and then I gave to this AI service the tool that is performing the search with DuckDuckGo. Okay, so I was chatting with a colleague that it's mostly a Python fan, and apparently in Python they have this contest and he said, okay, you cannot do this thing in Java, but of course you can. So the question is how many seconds would it take for a leopard at full speed to run through the Pont des Arts, okay? Which is a bridge in Paris. So of course, in this case, the LLM has to figure out that it doesn't know the speed of a leopard, and it doesn't know how long that bridge is. Okay, so this is pretty impressive. It uses the same. It has these two missing information. It uses the same tools twice. Once it asks, "Give me the speed of the leopard," and then it asks, "Give me the length of that bridge." And then so it finds these two information, and then it put together, do some simple math, and return the answer. So this is all made by the LLM. I didn't write a line of code. Of course, yes, it took me a bit of time to do some prompt engineering, but I didn't write a line of code, okay? And then this is the last example I have. Here I wanted to have also a conversational agent. So the agent and the example that you have seen so far are one single request. You don't have a conversation. You do a request and you receive a response, okay? I wanted to create a more conversational agent, so I gave to it a memory. What this agent is doing is a booking reservation agent for the restaurant. Okay, so this agent knows the geographical coordinates of the restaurant. So it calls the weather service that you saw before, but this time calling it with the geographical coordinates of the restaurant. And then it has this booking service that this time has a database. So when it's clear what are the user requests and the user is happy with the reservation, then it writes this reservation in the database. Okay, and as I said, you need to do some prompt engineering also here. So I wanted also to provide an example of what means doing prompt engineering and playing with prompt. The problem here is that you want this service to know the current date, okay? So I'm saying today is the current date, then it's up to Quarkus to replace the current date with the actual date. But in the user message, I'm giving to this thing the current date. Why I'm doing this? Because normally when you chat with an agent like this, you don't write a date. You say, I want to book a table for 4 persons.